there, geometry students. This is Mrs. Hefty here. Today we're talking about section 3-6, which is on perpendicular and distances. And so we're going to take a look at a distance. A point is from a line, and you have a picture there of line PQ with point M. When you're looking for distances, your distance from a point to a line is always going to be the perpendicular line. When you talk about distance, you're talking about the shortest length from a point to a line, and that is going to be perpendicular. So let's take a look at our first couple of examples. We need to find the distance from the point to the line. So what I'm going to have to do, we talked about distance being the perpendicular line from the point to the line that is given. So I'm looking at point C to line AB. I need to draw a perpendicular line. Now make sure you are drawing your right angle marking in there, or it will be marked wrong. In number 2, I'm going from T to RS. Now you may need to extend the line at times, people. At this point now, you're going to go perpendicular. So no, ST is not the perpendicular line. You need to go perpendicular at a right angle. So there I have it, and I'm going to draw my right angle marking. Let's take a look. We're going to have two parallel lines. When we're given two parallel lines, I'm going to draw a graph, and I'm given two parallel lines. Then I need to find the length of the segment that has an endpoint on each line, and it's going to be the perpendicular line. So I could go from this point to that line and make it be perpendicular. This is not the distance. This is not the distance. I see that all the time on the quizzes and the tests. That is not correct. You need to do the perpendicular line from a point on one line perpendicular to the other line is what you need to do. I broke this into two different sections because the two problems that come now take a lot of work. Find the distance between a line containing 4, 3, and -2, 0, and point P, 3, 10. So I've already plotted my points and drawn my line. I've got, here's my point P, and then I've got -2, 0, and I've got 3, 10, and I've got the line right here. So what I'm going to have to do, I need to find the distance, so I need to do the perpendicular line. So I'm going to let you have a graph so that you can kind of have a feel for what it's going to look like. But you're going to have to show all of the algebra. So what I'm going to do here is I'm going to take P and I'm going to do a perpendicular line to the line I've been given. Now I cannot just eye it up and then go ahead and try and figure out how long that line is. I really have to mathematically figure it out. I'm going to call this line line L. Okay, so I need to first find line L's equation, and I do strongly suggest that you write all these steps down. Pause the video if you have to. So to find line L's equation, first I need to find the slope of line L. So I'm going to go y minus y over x minus x. So I'm going to go 3 minus 0, and then, oh. Okay, let me erase that. I need to use the 2 points, which were 4, 3, and -2, 0. Those are line L's points. So yes, I am going to take 3 minus 0, and then I am going to take 4 minus -2. So my slope of L is going to be 3 over 6, which reduces to half. So now I have the slope of L. I still need to find the equation. So this was the first thing I needed to do when I find the equation. The second thing I need to do is go y equals mx plus b. Y equals, my slope is half x plus b. I need to find out where it crosses the y-axis, so I need to plug in one of those ordered pairs, and I am going to plug in -2, 0. So I'm going to go 0 equals half times -2 plus b, and I'm going to get 0 equals -1 plus b. So when I move my 1 over, I'm going to get 1 equals b. I was looking for the equation for L. So my equation for line L is y equals my slope, I found was half, x, what's my y-intercept? 1. All right, so I've got my equation. Now I need to find the distance from P to that line there. So what I need to do now is I need to write the equation for the perpendicular line. All right, so that's the next thing I'm going to do. So my second thing is I need to do the perpendicular. I need to do the perpendicular equation to line L. All right, when I look at the perpendicular equation, let's see if we'll extend it. I'm having problems here, guys. Okay, I was looking for the perpendicular equation for line L because I want to find that distance. So I need to find my perpendicular line right here. So to find my perpendicular equation, y equals mx plus b, I need perpendicular to the slope half, so I'm going to use y equals -2x plus b. Remember, it has to go through P, which was 310. I'm looking for that one right there. So I need to plug P in. So now I'll go 10 equals -2 times 3 plus b. 10 equals -6 plus b. And so now I'm getting 16 to be my b. So I have my perpendicular equation to line L, and that was y equals a -2x plus 16. Okay, so right now, guys, what I have is I have my two equations. I have the equation for this line, y equals a half of x plus 1. I have the equation for this line right here, y equals a -2x plus 16. I need to find out how far it is from P to here. So I would like to find the distance. I'm going to use my distance formula, x minus x squared plus y minus y squared. But I need to figure out where these two lines intersect. Where those two lines intersect. So I'm going to need to do a substitution or elimination is what I need to do. So let's go ahead and do our next step. And I'm going to move down here, guys. All right, so I'm on my third step now. My third step is to use substitution or elimination. And L was y equals a half of x plus 1, and the perpendicular was y equals a negative 2x plus 16. So because they're both equal to y here, I'm going to set them equal to each other. I'm going to take this, I'm going to write it right there. A half of x plus 1 equals 2x plus 16. I'm going to go ahead and get my variables together, minus my half of x. That's going to get me 1.5 x, or excuse me, here this is a negative 2. This is a negative 2. So that's a negative 2.5 x. I'm going to move my 16 and minus my 16, minus my 16. It's going to get me 15. So now I'm going to change this to 5 halves, right? 2 times 2 is 4 plus 1 is 5 halves, negative. I'm going to multiply by my reciprocal. I don't have a calculator, so this is the way I'm going to do it. 2 fifths negative, 2 fifths negative, canceling. It becomes a 3, so I'm getting my x to be, this is negative 15, this is negative, so I'm getting my x to be positive 6 at this point. Now I need to find my y, so I'm going to plug it in. I'm going to plug it into one of these equations. I'm going to plug it into this top one. Y equals half of 6 plus 1. Y equals half of 6 is 3 plus 1 is 4. So that ordered pair is 6, 4. At this point now, I want to find the distance. So the fourth thing is I want to find the distance. Let's go back up here to the graph. I know you guys have it and you can see it, but I got to scroll all the way up. All right, so I just found this point is 6, 4, and I can go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. Okay, I'm thinking that's probably right. And this is 4, 3. So now I need to use my distance formula between those 2 points. So I'm going to come down here. I need to find the distance between 6, 4, and 3, 10. All right, so do your distance formula. Distance equals, take your x's and subtract them, 6 minus 3 squared. Take your y's and subtract them, 4 minus 10 squared. D equals square root of 6 minus 3 is 3 squared plus 4 minus 10 is a negative 6 squared. D equals root 9 plus 6 times 6 is 36. D equals square root of 45. And now we need to simplify our root, guys. Simplifying our root, D equals 9 times 5. Square root of 9 is 3 root 5. All right, we do have another part to watch, guys. You may want to watch this again. This is a tricky problem, and I will expect you to be able to do this on a quiz or a test. You guys have a great night, and I'll see you in class tomorrow.